All right, guys, so today is day 2 of sinusoidal function transformations. We started this yesterday, and we started off with really easy questions, and then they got progressively harder. So just as a quick review, if you have a number in the front, that number represents your amplitude. If you have a number at the end, that number represents the equation of axis. And that makes sense because usually your A is your vertical stretch or compression, which affects your amplitude. And usually the number at the end is a vertical translation, and that affects where your equation of axis is going to be. Now, one of the things we didn't really get to, so I'm going to emphasize it today. Anything inside of here, we have to remember to factor it before we complete the question. And when we do that, we end up with the letter K, which is your phase shift. And the way that it works is your phase shift tells you, or sorry, it's not your phase shift, it's your horizontal stretch or compression. So usually a graph starts from 0 and goes to 360 degrees. But if you have a horizontal compression, it means the period is going to be a lot less. If you have a horizontal stretch, it means the period is going to be greater. So to figure that out, we're going to follow the little formula. Period is equal to 360 divided by K. And then the letter D is the phase shift. It's basically a horizontal translation to the right or to the left. And that's basically just your starting point. So we did a couple of examples. I also want to remind you what these graphs look like. So a positive sine theta graph looks like this, and a negative sine theta graph looks like this. It's just a vertical reflection. A positive cos theta graph looks like this, and a negative cos theta graph looks like this. And this is really important because it tells you the pattern of where you're going to be putting your points. All right, so let's go all the way to question number 6. Again, we're doing 4 questions. It will get repetitive, but hopefully that repetition will just stick in your mind and you'll get this really, really nicely. Let's begin by figuring out what the amplitude is. That's where we always start. There's no number in the front, so the amplitude is just going to be the number 1. And then I always figure out the equation of axis, which is going to be y is equal to positive 5. So basically, the midpoint of our graph is 5, and then we're going up 1 and down 1. So it's not going to be like very, very elongated. It's actually going to be kind of squished. Okay, so I know I need to go all the way to 6. 1, 2, 3, 4, 5, 6, 7. I used last time. I used the green. Okay, so we're gonna highlight y is equal to 5, and we're gonna make a dashed line there. And by the way, one of the things you want to look at before you start drawing your axes is where the phase shift is. Usually when the phase shift is to the right, like in this case, then I don't worry too much because I know there's not going to be anything to the left side of my graph. All right, so I'm going to label this line y is equal to 5. And then I'm also going to identify where my maximum and minimum are. So I'm just going to go up 1 for the maximum and down 1 for the minimum. All right, so I think we're pretty good at all that. Let's now figure out the rest of it. For this question, what is our K value? It's just going to be 0.5. And by the way, you'll notice everything inside of the bracket is factored, and that's how we want it to be. So we don't really have to do that work. It's already done for us. To figure out the period, remember the formula is your period is equal to 360 divided by K. And we just figured out K is 0.5. So we're going to go 360 divided by 0.5, which is going to give us 720 degrees. Let's see if this makes logical sense. So technically, our K value is a half, And we think of that as a 2, which means it's actually going to be a horizontal stretch. So instead of going from 0 to 360 degrees, does it make sense that our period is now from 0 to 720? It's double? It does, right? Because if you horizontally stretch a graph, it's going to elongate this way and it's going to be a greater period. So the math actually works out with like the logic of it. To get the quarter period, we're going to go 720 degrees divided by 4, which is going to give us 180 degrees. So something important happens every 180 degrees, a turn. There is a phase shift, and it's going to be 180 degrees to the right, because remember, if the number inside the bracket is negative, you go to the right. If it's positive, you go to the left. And then what you do is, in order to figure out what the template is, like what you're going to be actually putting on the x-axis, you look at your quarter period, you look at your phase shift, and you actually take the greatest common factor. So I'll write that down. Over here. You look at these two and you think about the greatest common factor, and the numbers are both the same. So really the greatest common factor is 180 degrees, which is great because that means we're just going to be going up by 180. For this question, let's go ahead and draw it maybe just for one cycle this time. We'll do 2 cycles for the other questions. So remember my advice to you yesterday, it was to put 180 in your calculator plus another 180. So you're going to have 180 and then 360 plus 180, and then just keep pressing the equal sign. 540, 720, 900, 1080. And by the way, this is 0. Now, if you're wondering, well, why did I not just go to 720? Like the period is only 720 degrees. So really I should have just done 0, 180, 360, 540, 720. Does anyone know why I actually kept going with my numbers and didn't just stop at 720? Sisha? Exactly. There's a phase shift of 180 degrees to the right. So we're actually not going to be starting at 0. That means I'm not going to be stopping at 720. I'm actually going to go past that. So you have to just be mindful of that when you're writing in your numbers. Just kind of look at the phase shift at all times. Okay, let's now figure out what the shape of this graph is going to be. So to do that, I look at the sign and the word cos or not cos. Gonna get maybe this one is a little nicer. And I'm going to draw out the shape right here. A positive cosine graph is just going to look like this. So the pattern is it starts at the maximum, it goes to the equation of axis, it goes to the minimum, it goes back to the equation of axis, and then it goes back to the maximum. Okay, but we're not going to start over here. Even though we're starting at the maximum, we know we're gonna go all the way to 6. We're not gonna start there because we recognize that there is a phase shift of 100 degrees to the right. So the first point is actually gonna be 180, 6. Then you're gonna move over a phase shift, sorry, a quarter period, which is 180, and you're gonna go to your equation of axis. You're gonna move over a quarter period and go to your minimum. Move over and go to your equation of axis, and move over a quarter period and go back to your maximum. Okay, and then if you are continuing the trend, just make sure you draw an arrow going down. That's what it's gonna look like, and then we label it. In this case, they're not using theta, they're just using x. So we're gonna go f of x is equal to cos square bracket 0.5 rounded bracket x minus 180 plus 5. Let's see if this actually makes sense. So our equation of axis is that y is equal to 5. Yes, that means there's a vertical translation up 5 units. The entire graph has been shifted up 5 units. Is the amplitude 1? Yeah, that's why it's really squished, because you're only going up 1 and down 1. There isn't a lot of vertical stretch going on. Is the period 720 degrees? So look, you start at 180, you end at 900. 900 minus 180 is 720. So from the start of your cycle to the end of the cycle, we have covered 720 degrees. Something important happens every 180. We can see that. There is a phase shift 180 degrees to the right, and we have a positive cosine shape. So that is the correct answer for our graph. When you have all the transformations, it is a lot to keep track of. So these questions can get a little confusing, but you're going to be practicing a lot, so you'll get good at them. Any questions about this? Nope. All right. 3 more examples. Let's try graph number 7. So this says graph f of theta is equal to -3 sine 2/3 theta minus 90, all factored. So that's great. That part is already done, plus 2. What is the amplitude in this graph? Yeah, 3, not -3. And the equation of axis is y is equal to 2. Yep. I quickly look at my phase shift. I notice it's a negative. That means you're moving to the right. So I can create my x and y axis where the x-axis is like shifted over. So that's fine. And then I'm basically, the middle of the graph is 2. I'm going up 3 and down 3. So I want a range of -1 to 5 when I'm putting in my numbers. So y is equal to 2. I'm going to draw a line there. I'm just going to pause this. Okay, so y is equal to 2 is my equation of axis. And then I'm just going to label the maximum. So your maximum value will be right here. And then 1, 2, 3, the minimum value will be down here. I don't know if you guys have noticed, but I always label those because then when I'm like figuring out my pattern, I don't have to keep looking at the y-axis. I kind of just look at where I've circled. That's as far as I'll go. You guys, what is the k value in this question? K is equal to 2/3. So when we're figuring out our period, remember period is equal to 360 divided by k. It's basically going to be 360 divided by 2/3. You can take the reciprocal, so you can make it 360 times 3 divided by 2 in your calculator. And I get a period of 540 degrees. The quarter period is going to be 540 divided by 4, which is going to be 135 degrees. So a little bit awkward. Our phase shift is going to be 90 degrees to the right. And finally, we have a question where we actually have to figure out a proper template because the numbers are not that nice. Okay, let me give you guys some advice on how to figure out the template, or how to find the greatest common factor. So you have a number like 90 and 135, and they're not as nice as the other ones. Obviously, we know for a question like this, 5 is definitely a common factor. The numbers I always pick are actually numbers we're used to seeing. So I always try 5, and then 15, 30, 60, 90, and also 45. I find that usually for anything related to trig, we often have like the special angle numbers like 45, 30, and 60. And then 90 is a quadrantal, and then 5 and 15. So usually, like most of the questions we're going to do are going to have a greatest common factor of one of these. There may be cases there might not be, but like I think all the questions you're going to be doing will have one of those. So looking at these two numbers, what do you think is the greatest common factor? I mean, we could try to do 135 divided by 30. It's not going to give you a whole number. We can try to divide both of them by 45, and you're going to notice that they are both divisible by 45. How about 90? 135 is not divisible by 90. So it seems like the greatest common factor is 45 degrees. That does take practice. And like I said, when you're doing the questions, if you complete all the homework questions, you'll notice a pattern. Like the greatest common factor, the template is always one of those numbers, it seems. Also, 180 is a common one, 360, any of the quadrantals. So always try the special angles and the quadrangles. That's my advice. Okay, so let's go ahead and write in a template of 45 degrees. And this question is going to be done in a way that we haven't really seen before. So I'll walk you guys through it. So we'll start with 45. Let's just do one cycle for this one as well. 90, 135, 180. All right, so where were we? So this is going to be 180 and then 225. You're going to notice I'm going to keep going and I'll explain why. 270, 315, 360. The reason I'm going is because, first of all, I know my period is 540. So for sure, I'm going to need quite a few numbers. And then also there is a phase shift of 90 degrees to the right. So factoring all of that in, you want to go to 540 and then a little bit more as well. I just want to rewrite this. Oh, I can't remember what that number was now. Okay, we'll come back to it. 405, 450, 495, 540, but I'm not going to stop at 540. I'm just going to keep going a little bit more. 585, 630. Let's stop there. Why do I feel that's a good place to stop? Because again, period is 540. You're moving 90 degrees to the right. If you go 540 plus 90, that takes you to 630. So that's probably going to be where you stop. What was the number after 135? What's 135 plus 45? 180. Okay, I'm probably going to struggle with this part, so maybe I'll do it later, extending that line. Okay, now here's my little trick or advice to you guys, because I do this question a little bit differently. We need to figure out what our actual quarter periods are, right? Because they're not 45 degrees. Our template is 45 degrees, but our quarter period is 135 degrees. So this is what I'm going to do. I know my starting point is going to be 90 degrees. So for sure, I'm going to be starting at 90. And then I need to move over 135 degrees. So 45 plus 45 plus 45 is 135. I basically have to move over 3 of these 45 degrees to get to the next quarter period. And I always note down where my quarter period will be before I even start. So you go 1, 2, 3. The next quarter period will be at 225. 1, 2, 3. The next quarter period will be 360. 1, 2, 3. Then it will be 495. 1, 2, 3. And then it'll be 630 degrees. So what I've highlighted are all the quarter periods. That's where something important happens. But the reason why we went up by 45s is because we have an awkward phase shift of 90 degrees. So those two numbers don't align. We had to find a common number that does align with both of those, so our graph makes sense. A graph of negative sign is going to look like this. So what we're going to do is we're going to start at the equation of axis, but we're going to also move over 90 degrees to the right. So 90 degrees to the right and start at the equation of axis. Then we're going to move over to the next quarter period. And because I've already highlighted it, I don't even have to think. It's going to be 225 because 90 plus 135 is 225. And we're going to go all the way to our minimum. Then move over to the next quarter period and go back to your 0. The next quarter period and the maximum, and then the last quarter period and a 0. So I actually just want to move all of this as well. And then we're going to try to draw a nice smooth graph. And we're going to label it, and we'll see if we're actually on the right track. So to label this, it's going to be f of theta is equal to -3 sine square bracket 2/3 theta minus 90 plus 2. Okay, let's do our check. So is the equation of axis y is equal to 2? Yes. Is the amplitude 3 at the top and 3 at the bottom? Yes, it is. From start to finish, have we covered 540 degrees? Well, we're starting at 90 and we're ending at 630. So 630 minus 90 is 540. So we have covered 540 degrees. Something important happens every 135 degrees. I know this because all of these are 135 degrees apart. That's why I had highlighted them. And then is there a phase shift 90 degrees to the right? Yes, there is. And I've drawn a negative sign graph because the sign graph has been flipped over. I also have arrows on both ends. You're not going to like this. Okay, so I'm going to just change this question because when I was just working it out, I've noticed that the number 4 is a little annoying. Change this to the number 3. So make it f of x is equal to a half cos bracket 3x minus 60 degrees plus 1. Okay, when you look at this question, what is the very first step that we should be doing? What's that? Good. I'm glad you noticed that because this question is not factored. We definitely need to start off by factoring it. So we're going to go f of x is equal to a half cos. I just use a square bracket. I'm going to factor out the 3, and I'll be left with x minus 20 plus 1. And now I'm going to be doing all of my work using this new equation over here. By the way, if you did the sheet or if you did the chart that I gave you guys last class, then hopefully you're pretty good at the factoring stuff because there were a bunch of questions. And if you have questions, I can answer those. All right. The amplitude is a half. The equation of axis is y is equal to 1. We're going to start with that. So basically, really, you don't need a lot of numbers. You just need, and I'm going to put in my halves as well. So I'm going to say this is a half, this is a 1, this is 1.5, and this is 2. So this is 1 and this is 2. My equation of axis is y is equal to 1. And I'm going to make that dashed. Like 10 more minutes? Yeah. So this is y is equal to 1. And then actually for your amplitude, you're only going up a half. So I'm going to label this right here a half, and I'm going to label this 1.5. So when I label this, this is your maximum and this is your minimum. Our K value is equal to 3. And if you didn't factor it out, you would have gotten the K value correct, but you would not have gotten the phase shift correct because it wouldn't be 20, it would be 60. So just be mindful of that. We're going to go 360 degrees divided by 3, which is going to give us 120 degrees. This just means there's a horizontal compression and the graph is a little bit more squished. Then we're going to go 120 degrees divided by 4, and that's going to give you 30 degrees. We have a phase shift, which is 20 degrees to the right. And then I'm going to look at these two numbers and figure out the greatest common factor to see what my template should be. 20 and 30 is pretty easy. What is the greatest common factor between 20 and 30? Higher than 5? Yeah, 10 degrees. So our template is going to be 10. Let's just do one cycle for this as well because we have to count up by 10s all the way to 120. So it's a little annoying. Okay, so we're going to have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. Well, we have 120 plus another phase shift of 20, so I actually need to go a little bit further. So I guess my advice to you is when you're figuring out what to put on your x-axis, look at the template and look at the phase shift to just figure out how many units you're going to the right and to the left. I went all the way to 150. I don't think you'd need to. You'd only have to go to 140, but I went up to 150. Okay, so whenever I have a phase shift and a weird like template, I figure out where I'm going. So the phase shift is 20 degrees to the right. That means I'm going to be starting at the 20. And then my quarter period is every 30 degrees. So 10, 20, 30, 10, 20, 30, 10, 20, 30, 10, 20, 30. I've highlighted 20, 50, 80, 110, and 140 because that is where something important will always be happening. My graph is a positive cosine graph, which means the shape of it is going to look like this. We're going to start at the maximum value and 20 degrees to the right. So the first point is going to be there. Then we're going to move the next quarter period over and back to the equation of axis, or to the equation of axis. Move over a quarter period and go to the minimum. Quarter period and equation of axis. Quarter period and maximum. Oh gosh. Not even really happy with this one. I'm not happy with the other one. No. Why can't you just be a smooth curve? Okay, that's as good as it's gonna get. And then I can continue this line down and this line down. Okay, and then we're just gonna label this, do we have to label it again? I guess we do. F of x is equal to, you could label it either or, so the original function or the factored one. We'll do our check. So our equation of axis is y is equal to 1. We're going half up and half down. Our period is 120. Let's see if it is. It starts at 20 degrees and it goes all the way to 140. 140 minus 20 is 120. And then a quarter period of 30 degrees. Something important happens every 30 degrees. We've moved over 20 degrees to the right, and that means it's the correct. I think 7 examples is pretty good. You probably have a good idea of it. All right, I'm going to stop this. I'll tell you what your homework is.